Hello learners, welcome to the NIOS studio. Now today we will continue that what are the types of strain. What is actually a strain? Let us consider that this length of the wire is of 10 centimeter, and if I apply a longitudinal stress, then it will get stretched. Therefore, it will give a rough estimation of some increase in its length, and there is a change in the configuration in terms of the length only. So, I can take the ratio in terms of its change to its original configuration of the length, which gives you a proper terminology for the strain. Therefore, we can state the ratio of change in the configuration to the original configuration is a strain. After implying a longitudinal stress, there is a change in the length, and the original configuration was also of a length. Therefore, both the terms will cancel each other in terms of its SI units, and it will give you a pure number. So, in the next slide, we define that strain being the ratio of two like quantities has no units and dimension. It will give a pure number. Now, we will continue that what are the types of strain. So, the very first type is a longitudinal strain. Longitudinal strain deals with only one-dimensional solid object, and it states that if the deforming force produces a change in the length alone, only the length, means the breadth should be negligible. And when we think of something which is having a length and a negligible breadth, we come across with the very first idea of a thin wire. Here, if we stretch this thin wire outwards, it will get change in terms of its stretched length. Therefore, longitudinal strain states that what is the actual stretch to the original length of the wire. For example, that before the stretch we take the length of the wire to be 10 centimeter, and after stretch it comes out to be 10.2 centimeters. Therefore, the difference in both the situations will give you the change in the length, which means 0.2 centimeters, and the original length will be 10 centimeter. And when we take the ratios for the change in the length to the original length, it will provide you with a pure number stating a longitudinal strain. The second type of strain is a volumetric strain, which states that if the deforming force produces a change in the volume alone, as well as we already know that volume is a three-dimensional object. Therefore, we can take the example of a sponge. As we can see, the sponge is having an original volume. Let us again assume it to be 10 centimeter cube. And if we try to compress or stretch the sponge, again let us say that we are having 10.2 centimeter cube of a change. Therefore, the change which comes into existence is again of 0.2 centimeter cube. And when we take the ratio of change in the volume to the original volume, it will give you the volumetric strain. Here again, there will be no SI unit as well as the dimension. And the last type of strain will be the shearing strain. Shearing strain, we need to remember that shearing means the force which acts tangentially over to the surface of a body. And if the deforming force produces a change in the shape of the body without changing its volume, will give you a shearing strain. As you can see from the very next slide, we are having a live example for normal stress in terms of compression and shear stress in terms of shearing strain. As you can see in the very next portion, the force is implied tangentially over to the surface of a cube. And when this happens, the length slightly slanted to the other end. This will give a shear strain. Now, we will discuss the stress and the strain curve. As we can see that we already plot a two-dimension curve consisting of stress on the y-axis and strain on the x-axis. Here you can see that the point A is defined by the proportional limit. The meaning of proportional limit is that if we imply the stress, or can say external normal force over to an object in a certain limit, then it will turn out to be a proportional limit. Till here, if the force is applied and when the deformed forces are removed, it will turn back to its original configuration. For example, we take a simple rubber band. If we stretch a rubber band in the proportionality limit and when the deforming forces are removed, it will turn back to its original configuration. But if we start increasing the stretch, the stress will get increased, and till a point, an elastic limit arises. The elastic limit states that if we further stretch the rubber band, there will be a permanent set, which means if the stress and the strain curve rises till the point C, a permanent looseness will appear in the case of the rubber band. So, if we stretch the rubber band till the point C, a permanent looseness will appear, which means it will not return back to its original configuration. After that, if we further imply a stress, more strain will arise and it will show a plastic behavior. The plastic behavior arises in between the area of C and D, where D signifies a fracture point. Fracture point is that particular point which states at that certain point of strain, the object will not regain its original configuration, as well as if we imply more strain, the rubber band will break into two parts. If we imply further strain from the point D, the fracture point will appear and the rubber band breaks into 2 points. Therefore, if the strain reaches the limit of point D, a fracture point is attained. And after the fracture point, if we further increase the strain, this rubber band will get into 2 parts. So, we can see after implication of the strain, even after the fracture point, the rubber band will be break into 2 parts. That's it for today. Thank you.